All right, class, hopefully the quizzes went well. Today we are talking about the library of functions and also piecewise functions. So the first thing we have to do is match each function to its graph. Some of these you should be able to recognize right off the bat, such as letter A looks like a quadratic. Now a quadratic, if you don't remember, another word for that is a square function because it is being squared. Oh, I don't know what just happened there. It's a square function. So that is what it's the same thing as square. E looks like a line. So if you look for that, it's not a constant function. It is the identity function because when x is 1, y is 1 as well. So it's like saying that 1, 1 is on that line, 2, 2 is on that line, 3, 3 is on that line. It's a line that goes through 0, and so on and so forth. Absolute value is a V shape, so that'd be D. A constant function means it has 0 slope or it's a horizontal line. You always get the same thing out, so that'd be B. A cube function is when it has, it's x cubed, and hopefully you know that that looks like F. The reciprocal function is the one that is like 1 over x. So that would be G. And by the way, I'm going to write these down actually, just so you know. Y equals x, y equals square root of x, which should be just c. And then the cube root is the sideways cubed one, which is h. Absolute value is absolute value of x, x cubed. Y equals a number, I'll just say a. Cube root is third root of x. Okay, so those are all of the our library of functions. So now we're going to sketch these functions and label the points on the graph. So y equals x. That is just a line that starts at 0 and has a slope of 1. The 3 points that we could put on there are 0, 0, 1, 1. And negative 1, negative 1. X squared has the points 0, 0, 1, 1, and then because of the squared, when you put a negative 1 in for x, you also get a positive 1. The cubed graph, cubed function, kind of looks like this and like that, and it has the point 0, 0. 1, 1. Most of these have the same 3 points. And negative 1, negative 1. The square root of x has only a domain of positive values, so it goes like this. And it has the point 0, 0, 1, 1. And then it has the point 4, 2, because when you take the square root of 4, you get 2 for y. The reciprocal function has asymptotes. So it has the point 1, 1 and negative 1, negative 1. It does not have the point 0, 0 though. You can say it has the point 2, 1/2 if you want. 2, 1/2. The absolute value function looks similar to a line except for, so that's the same as the line, but then this piece bends up. So this has similar points to a quadratic, well, similar 3 points, I should say. Oh, that's positive 1. So negative 1, positive 1 for the left side. The cube root is the sideways cube, so it's kind of like doing the square root both ways. And I have a 0, 0 here, a 1, 1 here, and again our negative 1, negative 1, because it doesn't flip up. And then y equals 3. Well, that's just a line, and y equals 3. So that means that no matter what x you have the value of 3. That's why it's called a constant function. Okay, so those are our library of functions. Again, you can pause the screen and look at them if you need to. And then I'm going to move on to piecewise. So piecewise. Use the given piecewise function to answer the questions between here. So you have to identify which piece is where. So I'm going to say anything to the left of negative 8 is in blue. Anything between negative 8 and 1 is in red. and anything that's greater than 1 is in green. So first of all, I'm going to look for any values that are greater than 1. That would be this one. So for this problem, I'm going to be using green, the green function. Between 8 and 1, including 1, that'd be all three of these, right? Negative 8 to 1. And then for this one, I'm going to be using blue. So find the value of f of negative 15. I have to plug negative 15 into the blue one. So I get negative 2, negative 15 plus 3, absolute value plus 1. So I get negative 12. That goes away because of absolute values. But then you have a negative here. So we have negative 24 plus 1 is negative 23. Then I move on and use this function for these three ones. So this is negative 5 plus 15, which would be a 5 plus 15 or 20. A 0, negative 0 plus 15 is 15. A negative 1 plus 15 is 14. Now I look at the last one. I have 8 I'm putting in, so I have 3/4 times 8. So 8 divided by 4 is 2 times 3 is 6. Okay? So really you're just plugging numbers into these equations. It's just telling you which equation to use based on your input. There are different inputs based on the domain. So again, if the input was less than 8, we use this equation. If the input was between negative 8 and 1, we use that equation there, the red one. And then if it's greater than 1, we use the green equation. And then we figure out what the values are. Alright, so graphing a piecewise. This is, if we're just doing lines, this is probably the easiest way to do it. I just individually graph both lines. So in the red, ignore this for now. Just say I'm going to graph 2x minus 3. So you start at negative 3 for your starting point, and you do a slope of 2. So I'm going to do that for the whole graph. And you guys might be thinking, well, we don't want the whole graph. And that is true. I'm not going to connect the line yet. So I have to find when x is 2. So when x is 2, there's a dot at 1. I then go, okay, that's going to be an open dot actually, because it is less than only. And then I have to figure out which way am I going. Am I going left or right? Well, this is saying I'm going left. I want all the values left of there. So I really want this part of the line. So I went towards the left for x's, which means I do not need the rest of these dots anymore. You're basically graphing this line like you did in Algebra 1, but you're graphing only the parts that matter. So this says start at 2 and then have a 1/2 slope. So I'm actually going to start there because that is where 2 is, and then it's going to keep going. And I know that I don't have to go backwards now because I'm going to the right. X is greater than 2. So there goes my line, and I have it, and I don't need that point anymore. That just helped me start the graph. So that would be my graph. Normally this line would go forever and this line would go forever, but it's like there's a wall at x equals 2 where it breaks and starts the other line. So if you find it easier for yourselves, draw the whole line and then erase what you don't want. And then just make sure the dots match up. Let's do it one more time. I'll do this one in red again. So I'm starting at 5 and it's a negative slope. Okay, so this one says it starts at negative 1 and goes to the left. So that would be an open hole here, and then the line going that way. So actually none of that other stuff matters. And again, I figured that out because it says x has to be to the left of negative 1. Well, here's negative 1 for x. So to the left of that would be everything that way. And that's how the line goes, so that is how we would draw it. This is a constant function between negative 1 and 7. So this means this has the points negative 1, negative 3, 0, negative 3, and so on and so forth. So we're down at negative 3. When x is negative 1, we get a y of negative 3, and so on and so forth. They're always negative 3, up until 7, which we also fill in. So this is just a straight constant line between negative 1 and 7. And that's the graph. We don't have any more because the endpoint was 7. It's equal to 7. So that is our piecewise function here. Piece of a graph, piece of a graph. Okay, so again, if you need to, draw the whole line. You can even use your calculator to help you out. Look at it on the graph like y equals negative x plus 5. Look at your table, plot all the points if you need to, and then go, wait a minute, I only want the values where x is negative 1 or less, and we don't want to include it, so we don't put it. Okay? We're going to keep going with piecewise, so if you're not for sure with this, we're going to have another video on this, the next video. We'll cover the rest of it. So, and until then, I will see you later.